In this video, I'm going to work several examples of solving rational equations that lead to linear equations, and just to make sure you're comfortable with this process. The first equation is 4 divided by the quantity x minus 2 minus 3 divided by the quantity x plus 1 equals 8 divided by the quantity x squared minus x minus 2. The first step is to determine the least common denominator, and to do that we need to factor x squared minus x minus 2. And this will factor as two binomials, x and x, 2 and 1, and we need a minus on the 2 and opposite signs because the last sign is a difference. So x squared minus x minus 2 is x minus 2 times x plus 1. Therefore, the least common denominator is a product of all the different factors, which would be x minus 2 times x plus 1, and they're only used one time in each of the denominators, so we only need one factor in the least common denominator. Then we have to be mindful of the restrictions on the variable because we cannot divide by 0. The expression x minus 2 is equal to 0 when x is equal to 2, and the expression x plus 1 is equal to 0 when x is equal to negative 1. Therefore, our restrictions are that x cannot equal 2 or negative 1. If those come out as a possible solution for the equation, then we have to exclude that. So now we multiply both sides of the equation by the LCD. 4 divided by x minus 2 times x minus 2 times x plus 1 minus 3 divided by the quantity x plus 1 times the LCD x minus 2 times x plus 1 is equal to 8 divided by x minus 2 times x plus 1, and then that is times the LCD x minus 2 times x plus 1. Then we can divide out any common factors between the numerator and denominator. In the first product, notice that x minus 2 is common, so we're left with just 4 times x plus 1. In the second product, the x plus 1 is common, so we're left with minus 3 times x minus 2. And then that is equal to the x minus 2 and x plus 1 is common, which just leaves us with 8. Simplifying the products on the left, we get 4x plus 4 minus 3x plus 6, right, be careful with the signs, is equal to 8. Combining like terms, 4x minus 3x is x, and 4 plus 6 is 10, so we have x plus 10 on the left equals 8. Subtracting 10 from each side, we get x is equal to negative 2. Negative 2 is not a restricted value, therefore the solution set is a set containing negative 2. A second example is 1 divided by the quantity x minus 5 plus 1 divided by the quantity x plus 5 equals x plus 3, all divided by x squared minus 25. The denominator x squared minus 25 is the difference of two squares and factors as x minus 5 times x plus 5. The least common denominator then is the product x minus 5 times x plus 5. The restricted values come from where those expressions in the denominator are 0, so that is where x minus 5 is equal to 0 or x plus 5 is equal to 0. And that gives us x is equal to 5 or negative 5. So those are our restricted values. X cannot be plus or minus 5. We multiply each side by the least common denominator, so 1 divided by x minus 5 times x minus 5 times x plus 5 plus 1 divided by x plus 5 times x minus 5 times x plus 5. And that is equal to the quantity x plus 3 divided by x minus 5 times x plus 5 times the LCD x minus 5 times x plus 5. Dividing out the common factors, x minus 5 divides out for the first product. We're left with just 1 times x plus 5, or x plus 5, plus, in the second product, x plus 5 is common, so 1 times x minus 5 is just x minus 5. And then that is equal to the x minus 5, x plus 5 divides out to leave us just x plus 3 on the right. Combining like terms, x plus x is 2x. 5 minus 5 is 0, so we just have 2x on the left, equals x plus 3. Subtract x from each side. 2x minus x is 1x, or x equals 3. And 3 is not a restricted value, so our solution set consists of 3. The next example is 2 divided by x minus 10 minus 3 divided by x minus 2 is equal to 16 divided by x squared minus 12x plus 20. We begin by factoring the trinomial, x squared minus 12x plus 20 factors as x and x, and the factors of 20 whose sum is negative 12 are negative 10 and negative 2. Therefore, the least common denominator is x minus 10 times x minus 2. The restricted values come from where those factors are equal to 0, so where x minus 10 is equal to 0, or at x equals 10, or x minus 2 is equal to 0, which is at x equals 2. So therefore, x cannot equal 2 or 10. Multiplying each side by the LCD, we have 2 divided by x minus 10 times x minus 10 times x minus 2 minus 3 divided by x minus 2 times x minus 10 times x minus 2 is equal to 16 divided by x minus 10 times x minus 2 times x minus 10 times x minus 2. Simplifying each product, x minus 10 divides out from the first. 2 times x minus 2, if we multiply that, we get 2x minus 4. Then note that x minus 2 divides out. And be careful here, we have a negative 3 times x minus 10, which is negative 3x plus 30. Right? The negative sign distributes to each of those terms. And then this is equal to just 16 since both factors divide out. Combining like terms on the left, 2x minus 3x is negative 1x. Negative 4 plus 30 is plus 26, equals 16. We can subtract 26 from each side to get negative x equals negative 10, and then divide by negative 1. So x is equal to positive 10. Hopefully that triggers a red flag because we just stated that x cannot be 10. So we have to exclude this value from the solution set, which means that there is no number that solves this equation. Therefore, the solution set is written as the empty set, right? No solution. And keep in mind that 10 solves this linear equation that resulted from clearing fractions, but it does not solve the original equation because it makes the denominator of the original equation 0. Another example is 1 divided by x minus 2 plus 3 divided by x plus 3 equals 5 divided by x squared plus x minus 6. It would be a great idea if you want to pause this and try to work this equation on your own and then check back with me in just a moment. The first step is to factor x squared plus x minus 6. And that factors by finding the factors of -6, whose sum is 1, which would be a -2 and +3. Therefore, the least common denominator is a product, x minus 2 times x plus 3. And the restrictions on x are the values that make those factors 0, which would be 2 and -3. So x cannot be 2 or -3. Multiplying each term by the LCD, we have 1 divided by x minus 2 times x minus 2 times x plus 3, plus 3 divided by x plus 3 times x minus 2 times x plus 3. And that's equal to 5 divided by x minus 2 times x plus 3. All of that fraction times the LCD x minus 2 times x plus 3. Divide out common factors and then multiply the remaining factors. So we have 1 times x plus 3, or just x plus 3 from the first product. In the middle term, the x plus 3's divide out, so plus 3 times x minus 2 is plus 3x minus 6. And then on the right, both factors divide out to just leave us 5. Combining like terms, x plus 3x is 4x. 3 minus 6 is -3, is equal to 5. We can add 3 to each side, so we get 4x equals 8. And divide 3 by 4 to get x is equal to 2. But again, hopefully a red flag is triggered because 2 is a restricted value, so we have to discard it. So there is no solution of this equation, which we indicate as the empty set. And then one last example, we have 4 divided by x plus 1 equals 7 divided by 3x plus 6. So to find the LCD, we need an x from the first denominator. We need a 3x, so 3x. And then we need the factors from 6, but notice that 6 is 3 times 2. We already have a 3, so we need another factor of 2. So our LCD is 6x. And then what are the restrictions? Well, the restriction is where the denominator is equal to 0, so where x is equal to 0, or 3x is equal to 0. But that's just at 0, right? X equals 0, 3 times x equals 0, divide by 3. And 0 divided by 3 is just 0. So the only restricted value is 0. Now multiply each of those terms by 6x. So we have 6x times 4 over x plus 6x times 1 is equal to 6x times 7 divided by 3x plus 6x times 5 divided by 6. Dividing out the common factor from the first product, the x is common, so we are left with just 6 times 4, or 24. 6x times 1 is 6x. 6x divided by 3x is 2. 2 times 7 is 14. 6x divided by 6, the 6's are common, which divide out, and x times 5 is 5x. So we can subtract 24 from each side, and also subtract 5x from each side. So this gives us just x is equal to -10. And -10 is not a restricted value. Therefore, our solution set is a set containing -10. So notice that in all of these equations, when we cleared fractions, we have a linear equation we had to solve. After solving that, we need to check to make sure that it's not a restricted value. And if it's not, we're good, but if it is, we have to exclude it.